Hello, this is the Math 136 3A review, part 1. We're going to be looking at how to graph the quadratic for this first example here. So it says let y equal x squared minus 6x plus 8, so definitely a quadratic because of the x squared being the highest power. State the direction of opening, that means does the parabola open up or down, the vertex, the x-intercepts, and the y-intercept, and the axis of symmetry, then graph. So when we look at this, I like to make a little list of all the things I need to know. So I need to know, does it open up or down? What is the vertex? What are the x-intercepts if they exist? The y-intercept, and the axis of symmetry. To tell if something opens up or down, if it's a quadratic, we look at the coefficient that is in front of x squared, which is 1. If that is positive, we open up. If it is negative, we open down. So in this case, we're going to open up, which means the parabola should look like this at the end, with the two parts going to positive infinity. To find the vertex, remember the vertex is an ordered pair, we use the shortcut formula of x equals negative b over 2a. So negative b is negative negative 6, because we'd be doing negative and then negative 6 over 2 times a, which is 1. So this is positive 6 over 2, which is 3. Remember, that is just the x coordinate of your vertex. Then we want to plug that back in to find the y value. So f of 3 essentially is what we're doing. So that's 3 squared minus 6 times 3 plus 8. So that's 9 minus 18 plus 8. That's negative 9 plus 8, or negative 1. So there's my vertex. To find your x-intercepts, you set y equal to 0, which means you're going to be trying to factor or use quadratic formula. Always try to factor first because, typically we try to give you something that's factorable. So this would be x minus 2 and x minus 4. It multiplies to positive 8 but adds to negative 6. So when we set each of those equal to 0, we get a positive 2 and a positive 4. Remember, that means that we have two separate x-intercepts, 2, 0, and 4, 0. And again, those make sense because they're equally spaced on each side of the vertex x value. The y-intercept, you plug in 0 for all the x's. So this is 0 squared minus 6 times 0 plus 8. So that's just going to be 8. So 0, 8. And then your axis of symmetry is always a vertical line that goes through the vertex. So it's x equals 3, because x equals a number is a vertical line, and that is the x coordinate of the vertex. So once we have all of our information, we want to graph this. So this is just make some marks, and on the test you'll have, of course, a grid where you can graph. You won't have to draw it by hand. And then a couple down here. So our vertex is 3, negative 1, so that's right here. Our x-intercepts are 2, 0, and 4, 0. Our y-intercept is 0, 8. And notice there will be a matching. See how this is 2 away from that x-intercept and then up 8? If you go 2 this way and up 8, there should be kind of a mirror image point over there. That's the symmetry. And then we draw the best parabola through all of the points. So there's a graph of number 1. So I believe number 2 is a very similar example, so let's go ahead and do that one. So it looks like our quadratic for number 2 has a negative in front, which means we're going to be opening not up this time, but opening down. So let's look at this. So let's go ahead and list all the things we want to know. So opens, vertex, x-intercepts, y-intercept, and axis of symmetry. Because of the negative 1 in front, that's going to be a negative, so that means we're going to open down, which means our parabola should look like an upside down U. Our vertex would be x equals negative b over 2a. So that's negative 2 over negative 2, which is positive 1. That's the x coordinate. We then plug that back into our function, or our equation here, to find the y. So that is negative 1 plus 2 plus 24. That's going to be 25. And then our x-intercepts, we set 0 equal to the entire function for y. So y is 0 now. And then we try to factor this. Now, to factor something that has a negative in front, you'll want to pull that out. and then try to factor. So this would be x minus 6 and x plus 4, different signs. So my x-intercepts are positive 6 and negative 4. So negative 4 comma 0 and 6 comma 0. My y-intercept I get by plugging in 0 for all the x's, which is just going to be 24. So 0, 24. And my axis of symmetry, remember, is my vertex x, so x equals 1. So when we go to plot this, I'm going to have to count by something bigger than ones here, so I'm going to make a notation of what I'm counting by. I'm going to count by 2's on both my x and my y axis. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we're pretty much just at the top up there. And then this will also be by 2, so 2, 4, 6, 8, 10, 12, 14, 16, 18. We won't need as many on the x-axis as we do on the y-axis. So I'm going to make a little note that this is 2, this is 4, this is also 2, this is 4, just to keep those straight. So when we plot 125, that's halfway between the 0 and the 2, and then all the way up above up here. So that's going to be way up at the top. And then negative 4 would be just 2 over this way, because remember this is negative 2, negative 4. So there's my negative 4, 0. My 6, 0 would be 3 away on this side, since I scaled everything. 0, 24 would be just right here. So then this is my graph of that parabola. So I had to scale it because the numbers got so large. If we had a graph and a lot of space, we could show you how skinny that really makes that parabola and how tall it is there. Okay, for 3 and 4, we're trying to take this standard form of this quadratic here and put it into vertex form, which is a times x minus h squared plus k. Anytime you see something squared, like a binomial square, that usually means that someone has completed the square to make that happen, especially when we're doing transformations. So the first step here is that you're going to make this 5 come out to the front, because we don't want it to be in our binomial part. We want this to be x to the first, or x 1x squared inside, because to complete the square we have to have a 1 in front of our x squared. So we're going to pull the 5 not out of the entire trinomial, but just out of the 2 first terms, the ones that have the x. So this would be x squared. 30 divided by 5 would be 6x. I leave a blank because we're going to complete the square. Close the parentheses, bring down that minus 3 that I didn't do anything to, and then this final blank over here I like to call the counter. Because whatever we do inside here to complete the square, since we're doing everything on the right side of the equation, we're not going to be adding it to both sides. So whatever we add or subtract inside here, we also have to consider the 5 out front, but whatever we do here overall, we want to counter it here, so it's really like we added 0. So I'm going to do my completing the square. So we take half the middle term here and square it. So half of 6 is 3, 3 squared is 9. So we are going to write a plus 9 in here. But the counter is that we actually did 5 times 9, which is 45, because this number out front is timesing by that positive 9 in there if we were to redistribute. So the counter to this, we need to counter this, so we're going to put in negative 45. So what that ends up giving us is f of x equals 5. This should factor nicely into a binomial squared. It's always the number right before you squared it. So x plus 3 squared. And then we add those together, so that's negative 48. So that's my vertex form. And then I want to list the actual vertex. The vertex is always the opposite value of the inside part, because this is negative h, but we actually say h when we report it as the vertex. So that would be negative 3, and exactly what we see for k, so negative 48. So there's my vertex. So let's do number 4. It's another similar version of this, except this time we have a negative in front of the whole thing. So the first step is going to be to pull that negative 4 out of the first 2 terms, the x terms. So that would leave me with x squared plus, because negative 16 divided by negative 4 would be plus 4x. we'd have our blank, close it, we still have the minus 10 at the end, and then our counter blank. So we're going to take half of the middle term, which is 2, and square it. So that's going to be that we're going to add in 4. But for the counter, we really did negative 4 times 4, because this is the part out front, which is negative 16, so we need to counter this. To counter it, we're going to use a positive 16. So this would be f of x equals negative 4. This will be x plus 2 since it was a positive 2 before we squared it, squared, and then that'll be plus 6. So my vertex is negative 2, positive 6. So there's those two. All right, let's look at number 5. Number 5 asks us to do the composite functions f of g and g of f. When I do these, I like to use colors. So I'm going to be doing red for f and blue for g. So this first one says take f and plug g into it. So f with g inside. So what I like to do is I like to write the red, the outside function, as if every time I see the letter x, I'm going to say blank. So this would be blank squared minus 5. And when I say blank, I usually write a parentheses. So this is the outer shell, kind of as an empty placeholder where there were x's. In those placeholders, that's where we put g of x, which would be 4x plus 7, the blue function. Then we work this out. So we would write 4x plus 7 times 4x plus 7, and then minus 5 gets brought over. This would be just foiling, so 16x squared plus the 28x plus another 28x plus 49 minus 5. Combine like terms, we would get 16x squared plus 56x plus 44. So there is f of g. Now we want to do the same thing, but this time we want to do g of f. Okay, so in this case, we write the blue function as the outside shell. So 4 blank plus 7. Inside that blank, we put the red function, which is the x squared minus 5. In this scenario, we don't have to square anything anymore, so we just need to distribute this 4. So this is 4x squared minus 20, and then bring down the plus 7 and combine like terms. Usually one of the compositions will be easier than the other one. So this one is 4x squared minus 13. Same thing for number 6. We're going to be doing f of g and g of f. So let's keep with the theme. We're going to call the f the red function, g is the blue function. So now this has been written differently. F of g, so I'm going to write this out here, of x is the same thing as f with g plugged in. The function that's closest to x is the one that's inside, the one that's farthest away is the outer shell. So then I write this, so I'm going to take my red function, I'm going to say the exact function, and anywhere there's an x, I'm going to write blank. So square root of blank plus 7. Inside the blank goes the 3x squared minus 2. The only thing we can do here is combine some like terms inside, so this is 3x squared plus 5 under the square root symbol. Okay, let's do g of f. So that would be g of f of x. So this time we would say 3 blank squared minus 2, and inside that blank goes the square root of x plus 7. We have a square root that's being squared, so it's just going to become x plus 7, which we will still have to distribute that 3 to. So this is 3x plus 21 minus 2, or 3x plus 19. So there's that one. For number 7, we have to do adding two functions together, subtracting two functions, multiplying them, and dividing them, and then state the domains of each. And our two functions are fractions, essentially. So they're rational functions. So when we add them together, so we're going to do all the adding, subtracting, multiplying, and dividing first, then we'll talk about domain. We need to get a common denominator. So the first one plus the second one, f plus g. and that's of x. So I would multiply top and bottom of this fraction by the x plus 4 so that they would have the same denominator as this one, and this one by the x minus 2. So then I would have all over x minus 2 and x plus 4. On the top here, I'm going to have x times x plus 4 plus 3x times x minus 2. You do not want to try to cancel anything here because there's still a plus sign right there. You're going to have to distribute out the tops. That's our next step. So this is x squared plus 4x plus 3x squared minus 6x. We can leave this bottom part factored out. And if we combine like terms, this is 4x squared minus 2x over x minus 2, x plus 4. Now, if you're being a good student, you'll double check to make sure if that top factors. It does. I'm just going to show this over to the side. But if you pull something out and it doesn't help you cancel anything on the bottom, we typically just leave it like this. So that doesn't give us anything that would cancel with the bottom. So there's the f plus g. So now we want to do f minus g of x. So it's the same situation except we're going to be subtracting. Where this one usually gets people in trouble is that they won't distribute the negative sign correctly when they do the common denominator. So again, we're multiplying this one by the x plus 4 and this one by the x minus 2 to get that common denominator. So this is x times x plus 4 minus 3x times x minus 2 all over the x minus 2, x plus 4. Broke that part off. This would be x squared plus 4x minus 3x squared plus 6x. So notice these two signs have changed. And then if we add our like terms on top, that's negative 2x squared plus 10x over x minus 2, x plus 4. And again, I could pull a negative 2x out of the top here, but that will give me an x minus 5 on top, which does not cancel with either one of the bottom binomials. So there's that one. So now we're going to do multiplication and then division. So f times g. That is not f of g, that is not composition, and composition is not multiplication. Those symbols are different. So this is just the first one, f, times the second one. Multiplication is pretty much the easiest one. You just do top times top, bottom times bottom. So this is 3x squared over x minus 2, x plus 4. You do not have to FOIL out the bottom. And then for division, we have to stack them. So we do f over g, and I do highly recommend stacking this as a fraction over a fraction first, because that helps you see the domain we're going to do in a minute. So we have that, and then I'm going to multiply this by the reciprocal, because this is division, so we multiply by the reciprocal of the bottom. Now something does happen here. The x on top can cancel with the x on the bottom because these are both monomials. So we just get x plus 4 over 3x minus 2. So there's that one. Okay, now notice I did that one in red. All the other ones were done in black. The domain of adding, subtracting, and multiplying are all the same. It is what are the combined domains of the two original functions, which means we go back up here and we say, okay, in this original function f, the only thing that was not allowed was 2, because if you plugged in 2, you'd get a dividing by 0. In this function, you couldn't have been negative 4 for the same reason. So the domain of the adding, the subtracting, and the multiplying is all based on what these two things have in common, which is they both need to throw out numbers. So it would be all the x's on the number line except negative 4 and 2. So there's the domain of adding, subtracting, and multiplying. Now if you needed that in interval notation, you could write negative infinity to negative 4, union with negative 4 to 2, union with 2 to infinity. But I'm okay for my students to just write it as x does not equal. And then for this one, there is a problem. Right here, everybody knows you can't plug in 2, you can't plug in negative 4. But there's another thing that's in the denominator of the original setup. This right here is now in the denominator of this big fraction right here. So we have to throw in another situation. X cannot equal 0 because of that. X can't equal 2 and -4 just because those were part of the original domain. So the domain of the division is X cannot equal -4, 0, or 2. So that is different. Okay, let's talk about number 8 next. So for number 8, we're looking at finding all the values of x such that f of x is greater than 0 and f of x is less than 0, and then sketching the graph. This is the polynomial that we're trying to graph, and when we're done, we'll have some interval notation that describes when are we above the x-axis, which is what this is really asking, and when are we below the x-axis. So the way that I teach this, now there's a couple different ways you could teach this. You can teach this by using a sign chart, where you just find your x-intercepts and then you set them up on a sign chart. You test values on each side and then you see if it comes out positive or negative overall. And that's one way of graphing it. I'm going to do this one by the sign chart, and then I'm going to show you how to do the other method for this one, the number 9. The only difference is if you're using my second method, which is we're going to look at behaviors, then you have to have the highest power of the entire polynomial. Whereas this is already factored, you would have to think, if I FOILed that all back out, that'd be, since all these are the first power, it would end up still being x to the third if we multiplied everything back out by FOIL, or distributive property if you want to be more specific. So depending on which way it's set up, sometimes one method might be a little bit easier than the other. So I'm going to use a sign chart to do this one. And I'm going to use behaviors to do this one. So I'm going to show you two different ways. And like I said, they both rely on us getting the x-intercepts first. So you need to have it factored. So this one's already factored. So the x-intercepts here are 3, -2, and 5 if we set each of those equal to 0. So if you're doing a sign chart, you just place those on the sign chart in order from least to greatest. So this would be -2, this would be 3, and this would be 5. You think about your intervals. This is -infinity to -2, -2 to 3, 3 to 5, and 5 to infinity. Notice I'm not putting brackets on any of these because we didn't ask when are we equal to 0. And then we pick test values for each one. So this would be -3, 0, 4, and 6. We think about our factors, which are x minus 3, x plus 2, x minus 5. And we're not really worried about whether or not it's greater than or equal to 0 yet. That's going to be part of our final answer. So we're just going to get the overall sign. So -3 minus 3 is negative, -3 plus 2 is negative, -3 minus 5 is negative. 3 negatives multiply to be a negative. So that means this is going to be below the x-axis. 0 minus 3 is negative, 0 plus 2 is positive, 0 minus 5 is negative. 2 negatives make a positive. That means this is going to be above the x-axis. 4 minus 3 is positive, 4 plus 2 is positive, 4 minus 5 is negative. 1 negative overall is negative, so we're going to be below the x-axis. 6 minus 3 is positive, 6 plus 2 is positive, 6 minus 5 is positive. 3 positives is positive when we multiply, and therefore we're above the x-axis. So if you've done it using a sign chart, you've pretty much got everything right there you need. You need to plot your x-intercepts. So let me put some values down first. And remember, we don't care on this graph about how high or low you're graphing your y-coordinates. Some people will have you find the y-intercept, and that's fine. You just plug in 0 for all your x's and you can mark that, but I'm looking more for general shape when I grade this for my class, so you'll just have to defer to whatever your teacher says. But I'm going to plot my x-intercepts, which remember are these guys right here. So -2 and 3 and 5. This tells us on each side of these what we're doing. So on -2, we're below on the left, but above on the right. So below, above. Then you always have to head back towards your next red dot, your next x-intercept. So notice, at 3, I'm above on the left side, which makes sense, but now I'm going to be below. So I go down, some unknown amount, and head back towards this next red mark. So I was down on the left of 5, and now I'm going to be above. Okay, so then for the test, there'll also be a place for you to write when is f of x greater than 0 and when is f of x less than 0. Greater than 0 was when we were above, so that would be -2 to 3 unioned with 5 to infinity. And then less than 0 is when we're below, so -infinity to -2 unioned with 3 to 5. And that's it. Now, the way I taught this in my class is we examined the behaviors. So the things that we looked at is first we found our x-intercepts, and we had to factor sometimes to do that. In this case, we do. I'm going to try factor by grouping. So that would be an x plus 4 minus a 1 we can pull out, and that's also an x plus 4. So this is x plus 4, x squared minus 1, and then that factors into x plus 4, x plus 1, x minus 1. Okay, and then so my x-intercepts, I called them, remember they're my zeros. That is -4, I put them in order from least to greatest, then -1, and then +1. So make sure those are in order so it makes sense when we read from left to right. I talked about the multiplicity, which means how many times did each answer occur, and then we talked about how that each of those things, the multiplicity tells us a behavior at the x-intercept. So since each of these has a power of 1, that means each factor occurred only one time. If your behavior is that you only occurred one time, you go straight through. You cross straight through the x-axis. At that point. If you have an even multiplicity, you actually bounce. You hit the x-axis and bounce back the direction you were already at. So if you're above, you would stay above. If you have an odd multiplicity that is bigger than 1, so like 3 or 5, you cross kind of at a squiggly like x cubed, sort of like that. Not perfect, but that's kind of what that means. You cross like x cubed. So for us, these are all just crossing straight through, so it's going to look very similar to my last graph. And then the other thing we had to know, besides just what happened at our x-intercepts, what's the behavior, we needed to know our end behavior. And end behavior has to do with your degree overall of your highest power when you were in standard form of the polynomial, and then your leading coefficient. If you had, so I'm going to make a little sign chart over here. If your leading coefficient is positive, or your leading coefficient is negative, if your degree is even versus your degree is odd, then we had to look at how this is broken down. So if you have an even degree and your leading coefficient is positive, both of the end values were up. If you had an even degree and the leading coefficient was negative, both of the end values are down. If you have an odd degree and you had a positive, then you're down on the, and for your leading coefficient, you're down on the left and up on the right. If you have a negative leading coefficient and an odd degree, you're up on the left and down on the right. So our degree is a 3, which is odd, and our leading coefficient is positive. So that means we are this scenario right here. Down on the left, up on the right. So this is just a different way of thinking about graphing instead of using a sign chart. So this is all based on behaviors. So -4, and it's going to be one of my x-intercepts. -1 is another one, and +1. I know my end behavior tells me that I am down on the very far x-intercept, so that's this one. I'm up on the very far one to the right, so that's what we mean by down on the left, up on the right. And then this tells me what to do as I go along. At -4, I'm supposed to cross straight through. That means go up. Come back down towards this. At -1, I'm also supposed to cross straight through, so that means keep going through. And then at 1, I'm also supposed to cross straight through, so it does make sense that it goes up. So f of x is greater than 0 at -4 to -1, because that's when I'm above the x-axis, and then from 1 to infinity. And then we are below the x-axis, or less than 0, from -infinity to -4, unioned with -1 to 1. And that's the end of number 9. Number 10 says use synthetic division to determine whether or not x plus 5 is a factor of this large polynomial. To do that, we need to solve for the 0 here. Because when you do synthetic division, you use the 0, not the factor. So that would be -5. We place that in our little box for synthetic division. And then we make sure we're not missing any powers. We are missing, it looks like x to the first is missing, so we'll need a placeholder for that. So this is a 6, a 28, you just use your coefficients, a -15, the 0 for the placeholder, and then the 128. If you don't use your placeholder, you will miss the problem. You always bring down the first coefficient, and then we start multiplying, and then adding, because we don't need to subtract since or change signs because we've already done that when we solved for the factor for the 0. So -5 times 6 is -30. Add the column, we get -2. -5 times -2 is +10. Add the column, we get -5. -5 times -5 is +25. Add the column, we get 25. -5 times 25 is -125, which means we get a -5 for our remainder. Which, unless your remainder is 0, then you are not actually a factor of this polynomial. Because to be a factor, you have to go in evenly. So x plus 5 is not a factor of the polynomial because the remainder is not 0. Okay, so that's the end of that one. All right, we're going to do number 11, and that's going to be the end of part 1. It says find the quotient, and actually maybe 12 too, because they're the same. So for number 11, it says find the quotient and the remainder of f of x divided by p of x when f of x is 4x to the fourth plus 6x cubed plus 5x minus 7, and p of x is 2x squared plus 1. So because we are not dividing by an x to the first power, this is not x to the first power, you can't use the shortcut of synthetic division. So we're going to have to do long division and say 2x squared plus 1 needs to be divided into this large polynomial. Now we use this, but we make sure there's if there's place values missing, we put in a 0. So 4x to the fourth plus 6x to the third. We don't have an x squared, so we'll need a placeholder, plus 5x minus 7. The first question we ask is what would we multiply this by to create this first term? So 2x squared times what would be 4x to the fourth? And the answer to that would be a 2x squared. You multiply the answer you get up here times everything out front. So that would be 4x to the fourth, and 2x squared times 1 would be 2x squared. When we do long division, we do have to change the signs just like in regular long division. So we subtract the part we just got from multiplying. That should always cancel out this first column, and then we bring down everything else. So this is 6x to the third minus 2x squared plus 5x, and then the minus 7. Our next step is to ask what would you multiply 2x squared by to make 6x to the third? And I would say I would need a 3 and an x, and so that'd be positive 3x. Multiply this by everything out front. So that's going to be 3x times 2x squared would be a 6x cubed. 3x times 1 would just be 3x, but then we have to remember to subtract what we just got by multiplying. That should make this cancel, and we bring down everything else. This is negative 2x squared plus 2x minus 7. Now I should be on my last round because I need to put this into this term. So for this last one, you should notice that you should have almost the same power here as you do up here. So 2x squared multiplied by what makes negative 2x squared? That would be a negative 1. We multiply that by everything out front, and we get negative 2x cubed, or squared, sorry, it's x squared, and then negative 1. But we have to go back and remember to change our sign. So this becomes a plus and a plus. So then my final thing is a 2x and a minus 6. So my quotient, because they're going to ask for that, is what we got on the top. So it's the 2x squared plus 3x minus 1. My remainder is the 2x minus 6. And I know it's my remainder because x squared cannot go into x to the first. We've gone as far as we can. Okay, for number 12, it's very similar, except this time we're dividing by x to the first. If you're dividing by x to the first, you can use synthetic division. So we would solve this, set equal to 0. So we're going to be putting 2 into, and again, look for missing powers. So negative 2, we're missing an x cubed. Then a 3, we're missing x to the first, and then a minus 2. Bring down the negative 2, multiply, get negative 4. Add the column. Multiply, get negative 8. Add the column. Multiply, get negative 10. Add the column. Multiply, get negative 20. Add the column. When you do synthetic division, this new polynomial right here is always 1 degree less than what you started with, because we divided by x to the first. So this would be negative 2x to the third, since we started with x to the fourth, minus 4x squared, minus 5x minus 10, that's my quotient. My remainder is just what's in the remainder box. And if you're dividing by x to the first, it's just going to be a number. It's not going to have an x on it. Okay, that's going to be the end of the part 1 video.